Number 14, follow the steps below to find the non-negative numbers x and y that satisfy the given requirements. Give the optimum value of the indicated expression. Complete parts A through F below. So our problem here is that x plus y has to be 120, and we want to find the optimum value of p equals x times y. Now, this is a perfect example of an area problem. Let's say we have 120 feet of fence, and we want to know what is the maximum area. So the first thing they tell us we need to do is solve the first constraint for y. So y equals 120 minus x. So what we're trying to do is we're trying to get our equation in terms of one variable only. So we have two variables and two constraints, so we need one equation though. So if p is equal to x times y, and we just found y to be 120 minus x, then 120x minus x squared is our formula for p. So p equals 120x minus x squared. Now, of course, you can rewrite that with a square in the front if you want to, but you don't have to. Now, the next thing they ask us for is the domain. And the important part here is it says they have to be non-negative. So if x plus y equals 20, and neither number can be negative, the smallest a number can be is 0. The largest the number can be is 120. Because if you go less than that or more than that, you're going to need to involve negative numbers. So our domain is all numbers between 0 and 120. The next thing it asks us to find is the derivative of p with respect to x. So that's p prime. That's going to be 120 minus 2x. So that's our derivative. 120 minus 2x. And when it's equal to 0, what is x? Well, if we solve that, 120 minus 2x is 0. That's 120 is 2x, and x is 60. So x is 60. So there was only one solution. Now for that value, what is p? Now p is x times y. If x is 60, well then y has to also be 60 because they have to add up to 120. So 60 times 60 would be 3,600. Okay, one more time on that. We've found our x to be 60 from our derivative. If x is 60, y has to be 60 because these two have to add to 120. So our p is 60 times 60, and that's where I came up with the 3,600. Evaluate p at the endpoints. Now remember that on a limited domain, that is an interval, the maximum on that domain can occur at the point where the derivative is 0 or at the endpoints. So the lower endpoint is x equals 0. Well, if x is 0, y is 120. It has to be because they have to add up to 120. So our p would be 0 times 120, so that would be 0. And if we're at the upper end, that is x is 120, that means y would have to be 0, so we have the same answer there. So evaluate the endpoints. In both cases, in this context, they are 0. Now, we could change our endpoints, but right now that's where our endpoints are, so they both came out to be 0. So the maximum value of p, as well as the two numbers x and y, whose product is that value? Well, p is 3,600 when x is 60 and y is 60. Number 15, complete parts A through F below to find non-negative numbers x and y that satisfy the given requirements. Give the optimum value of p. So our constraint is x plus y is 75, and p is x squared times y. And We want to maximize x squared times y. So following the similar path we took before, we need to subtract x from 75 in order to find y, right? Because if x plus y is 75, we have to take an x from both sides to get the value for y. Now they want us to write a formula for p using only x variables. So it's x squared times 75 minus x. And I can multiply that out as 75x squared minus x cubed. Let's see, 75x to the second minus x to the third. Find the domain. Well, the domain has to do with the fact that these have to be non-negative and that x and y have to add up to 75. So similarly, the lowest you can go is 0, and the highest you can go is 75. That keeps you out of the negative number set. Now we're going to take the derivative of p, the derivative of p with respect to x. Another way to write that is p prime. That's 150x minus 3x squared. I'm going to solve this, so I can factor out a 3x. That's going to give me a 50 minus x, setting each factor equal to 0. X is 0, or x is 50. So our two solutions are 0 and 50. You should be able to put them in either order, doesn't matter. Now we have to evaluate. If we're going to do the maximum on a fixed interval, it has to occur at the point where the derivative is 0 or at the endpoints of our interval, which we said were 0 and 75. So they're going to have us evaluate p of 0, p of 50, and p of 75. That's the two endpoints and the point that we found where the derivative is 0. Well, if we're going to put 0 into this expression, this is our p expression, we're going to get 0, 75x squared minus x cubed would be 75 times 0 squared. So 75, 0 squared minus 0 cubed, that's going to be 0. If we put 75 in, that's going to be 75 times 75 squared minus 75 cubed. Well, that's 75 cubed also, because there's two of them here and one more here, so that's going to be 0. So the only one we really have to evaluate is 50, so it's 75 times 50 squared minus 50 cubed. So let's see how much that is. So 50 squared is 2,500 times 75 is 187,500. 50 cubed, 50 to the third, is 125,000. So the difference between those is 62,500. So once again, we're going to find out that it's at the point where the derivative 0 is our optimization of this problem. So this one, P of 50, is 62,500. And this one, we also got 0. So the maximum value of P is 62,500. The values of x and y are, well, let's see. If x plus y has to be 75, and we found x to be 50, then y has to be 25. So 50 and 25.